Do you have any question in the homework? Fine. We have homework number 10 tonight. It is the second homework using the base rule and the rule of the total probability. And now I posted the new one, 11, will be due Friday from chapter 5. It's a today's topic. But any question, another homework for base rule? Is it good? 5? Okay. Okay, today, the new one. Discrete random variable. It's a new topic. First of all, have you ever heard the discrete? The wording discrete? Do you remember? You know the very beginning, I think in chapter 2. In chapter 2, we had two types of the variables. Can you remember the two types? Very beginning, we had two types. One was the categorical variable, and the other one was the numerical variable. It's a qualitative and quantitative. Good, right? Only for the numerical, we had another two types. Do you remember another two types for the numerical? One was the discrete, and the other one was continuous. Here was the discrete, one of the type of the numerical variable, discrete. Yes, now the discrete is the discrete. Discrete, one of the types. For whom? Numerical variable. So now I can say today we are going to discuss the random variable in chapter 5. The random variable is numerical. In chapter 5, we are going to discuss the type, discrete numerical variable. What do you expect in chapter 6? In chapter 6, we are going to discuss continuous random variable later in chapter 6. So now, please remember, random variable is numerical, only the numerical. Chapter 5, we are going to discuss the discrete type. What was the discrete type? Countable. Simply, I can describe the discrete type is a countable, continuous type, uncountable. So we are going to discuss the countable, the numerical variable, discrete, random variable. Now, then you should understand what is the meaning of the random. How do you think? What is the random? Now here is the definition. Here is the definition of the random variable. Random variable is a quant. It's quantitative, it is numerical. What I said. Then what? Depends on chance. By chance. The other way, with the probability. We are going to use the probability. That is the reason why we discussed the probability in chapter 4. We already discussed about the probability in chapter 4. Now, in chapter 5, we are going to use it. Because the random variable is a numerical variable with the probability by chance. I can show you an example. Example 5.2. Here's the numerical variable, is the number of siblings. the number of siblings. Countable. Numerical variable. Actually, it is a discrete numerical variable. Can you see the second column with the probability? So now the numerical variable, the discrete numerical variable, will be a random variable, a discrete random variable. So the x equals 0, no siblings. What does that mean? Only child. Anybody only child? Are you? Are you? You? Anybody who has one brother or one sister? Good, right? And two brothers, two sisters, or brother and sister? Thank you. It's up to 4. Now here's just up to 4. Anybody who has a 5 more than 5? How many? Oh. Including. How many? 5. Including you 6? Yeah, including you will be 13.
It's over that. There's more.
Okay. Same. Yeah. I'm sorry, we just cut. It's too much, too many, right? So this example just because it's up to 4, right? And here is the probability. In chapter 2, we made the frequency table. You remember that? Even though it didn't suggest us as how many students who has no sibling, one sibling, two siblings, but there is a probability. You know, the probabilities is kind of the relative frequencies. Can you remember the relative frequencies? When we made the frequency, yeah, that is the probability. And in chapter 2, with the numerical variable, we made the frequency table, and sometimes with the relative frequencies, the probabilities, and we made the histogram with the numerical variable. Random variable is a numerical. Why not? We can make a histogram. So now with the random variable, I can put this more scales. Here's a 0.30 and 0.40, and no siblings. There is a 20% and 42.5%. Yeah, roughly I can make the histogram, but please make as a better one. And less than 10% and less than 5%. Yeah. Why not? Random variable is a numerical, so we can make the probability table. And now I can call this one is the probability distribution table. And also we can make the histogram. It's a numerical variable. Okay, it's good. I can show you another example. Yep, here. We are tossing 1.3 times. In chapter 4, when we discuss the probabilities, first, we should understand what is the experiment clearly. Toss a die 3 times. What was the second one? In chapter 4, we have to consider a sample space. What was the sample space? A collection of all possible outcomes. Now we can think about the 8 equally likely possible outcomes in the sample space. So now here's a big S, the sample space. Let me see. We are tossing one coin 3 times. H, H, H. Head, head, head. Can be one outcome. The other one will be head, head, tail, head, tail, head, head, tail, tail. First of all, we consider 4 outcomes. When I got the first head. And the other 4 outcomes can be first, tail. Tail, head, head, tail, head, tail, 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 head, and the last one will be T, T, T. How many possible outcomes? 8 possible outcomes. in the sample space. Now, let me think about a random variable. The random variable must be a numerical variable. And now, in chapter 5, we are discussing the discrete type. So now the random variable is the number of heads. Number of counts. How many heads, right? How many? How many heads? 1, 2, 3. 2. 2 again. There's only 1. T. No head. So now we can consider is x equals 0. What does it mean x equals 0? No head. Which one? T. Only one outcome. T. Only one outcome. T. We can interpret no head. That is the random variable, which was the number of heads is equal to 0. Now the second one is equal 1. Only one head. Then how many tails? 2 tails, right? Yeah. This one. Oh, I'm sorry. This one, and that one. How many outcomes? 3 outcomes. H, TT, THT, TTH. 3 outcomes. X equal 1. 1 head, 2 tails. What is the next? X equal 2. 2 heads, how many tails? Only 1 tail. So 2 heads, 1 tail. HHT, HTH, and this one, THH. So far so good? And the very last one, x equal 3, all 3 heads. Only one outcome, which is HHH. The variable x, the number of heads, it is a discrete numerical variable. But if I want to say it is a random variable, then now we need the probabilities. We have to assign the probabilities. The case of x equal 1, I mean the x equal 1, x equal 0. How many outcomes? 1 outcome out of how many was in the sample space? 8. So the probability will be 1 out of 8. Because now we have only one case, one outcome out of 8 possible outcomes in the sample space. The next one, x equal 1. How many outcomes? 3 out of 8. X equal 2, another 3 out of 8. X equal 3, only 1 out of 8. Can you assign the probabilities? Yeah, so now we have a numerical variable with the probabilities. It is a random variable. When you sum up, when you take the sum of all probabilities, how much do you expect? Always 100%. Yes, always 1. It is the most important properties, one of the most important properties for the random variable. Any kind of random variable, yeah, we are going to discuss the continuous random variable later in chapter 6. But any kind of random variable, when we sum up all possible probabilities, it must be 1. 100%. Always. Please remember. So when you assign the probabilities, and you can check by yourself. It's like as the tree diagram. Sum up, always 100%. So you can check by yourself. Okay, so now we have a new topic, discrete random variable. Random variable is a numerical variable. So in chapter 2, we made the frequency table histogram with the probabilities. And now, please remind what we did in chapter 3. In chapter 3, the title was, maybe it was something I cannot remember the title. But in chapter 3, we discussed some statistics with only the numerical variable. Can you remember that? We describe the numerical variable. We describe the distribution of the numerical. And we measure of the center. And we had 3 statistics for the center: mean, median, mode. And we measured variation. The measure of the variation. We had another 3 statistics: range, variance, standard deviation. Can you remember that? The 3 statistics for the center and the other 3 statistics for the variation in chapter 3 with the numerical variable. So now, why now? Random variable is a numerical. We are going to take the mean for the center. We are going to take the standard deviation for the variation. For whom? Random variable, right? So here's the formula. Yeah, don't look at this. Yeah, we are going to look at this one later. Yeah. But anyway, we are going to take the mean of the random variable. Here's an example. Now I have 8 students, and I ask them, how old are you? The first student is 19 years old. Second is 20, 20, 19, 21, 27, 20, and 21. Let me make the frequency table. It is a discrete random variable. So let me make the frequency table. It's how many 19s? 2, 19, 19, 2. And how many 20s? 3, 1, 2, 3. How many 21? 2 and 127, totally 8. Now I can take the relative frequencies. Simply take the proportions. 2 out of 8, 3 out of 8, 2 out of 8, 1 out of 8. 2 out of 8. Simplify 1/4, 0.25. The probability will be 0.25 for 19 years old. 3 out, I don't know. Let me try. 3 as a decimal, 3 out of 8. It will be 0.375. Probability will be 0.375. And 2/8 is another 25%, it's 0.25. And 1 out of 8. It is a 0.125. 0.125. How much will be the sum of the probabilities? Always 1. Yes. Always 100%. That is 1.00. So we had a random variable. Now we have a numerical variable, age in years. 19, 20, 21, 27. With the probabilities. Now it is the random variable. I need the average. I need the average of the age. So first of all, we have to take the multiplication. Age times the probability. Another age times its probability for each. So now I can write here 19 times 0.25. 20 times is 0.375. 21 times is 0.25. And the oldest one, 27 times is 0.125. take the multiplication first, and then take the sum. So now, let me see. 19 times 0.25. I have a 4.75. And the second addition and second multiplication, 20 times 0.375 will be 7.5. And 21 times 0.25 will be 5.25. And the last one, 27 times 0.125, it will be 3.375. Now take the sum. 4.75 and 7.5 and 5.25 and 3.375. I have a 20.875. What's this? It is the average of the ages. It is a mean. How? Take the multiplication and then take the sum. Good, right? Then now let me look at the formula. This is the age times the probability. Then what? Take the sum, sigma. Exactly what we did. Take the multiplication each and take the sum. That would be the mean. Now we are using the Greek letter. Looks like U, but it is the mu. We are going to use the mu. It's a mu. It's a mu for the mean. Sometimes we call this one is an expected age, expected value, or expectation, because when I have the age students, randomly I select one, then I can expect the age will be 20.875. Even though before I'm asking he or she, how old are you? But at least I can expect the age will be 20.875 from the distribution, from the table. So the mean average can be described as the expectation, the expected age. So it's the same thing. The average, mean, or even the expectation, that is the same thing. 20.875. Okay, it's good. So in this way, yeah, we can take the mean. Next one will be the standard deviation. Equation? Yeah. Equation will be the x value times probability. The random variable is equal to the value. Then take the sum. Now, the x value, they are the age. Okay, now we are going to take the standard deviation. Standard deviation. We got standard deviation before in chapter 3, and we applied many steps. Can you remember how many steps we applied before? 6 steps, yes. 6 steps. Can you remember them? Step number 1, we take the mean. Yeah, here's another. Don't look at this. I will explain to you one by one, but it's too much. Okay, chapter 3. In chapter 3, already we took the standard deviation. The symbol was the small s for the sample standard deviation. Step number 1, we take the mean, x bar. You know, now the mean is another Greek letter, is another symbol, mu. Before we stated sample mean was x bar. Step number 1, we take the sample mean, x bar, average. Step number 2, what? In chapter 3. I knew it, yeah, after exam. Why not? You forgot everything. In step 2, we take a difference. It's a value, a sample minus the x bar. Step 3, square, thank you. And then we take the sum divided by n minus 1. I didn't explain yet why we have to do 1 off. Yeah, please wait, not yet. But we divided by n minus 1. Finally, in step 6, we took the square root of it. By 6 steps, we took the sample standard deviation. Step number 1, we take the sample mean. Step number 2, take the difference. It's actually the mean was the center. And the distance, the difference, that is the distance, right? And we have to make them all positive, square, and take the sum divided by n minus 1 is kind of the average. But because we took square, finally, in step 6, we have to take the square root of it to get the standard deviation. Remember the 6 steps, right? Okay, now, let me look at the formula. Now here, with the random variable. First of all, we take the mean. The Greek letter mu, it is the mean. Step number 1, same. Before we take the x bar. Now the mu first, same. Second step, we take the difference. We take the difference. Same. What we did in step 3, we took square. Now we take the square, same. So far so good. So far same. Right? We take the sample mean, we take the difference, and we take the square. The first 3 steps are same. But now, before take the sum, we take the multiplication. Before take the sum, we have to take the multiplication with the probabilities. And then take the sum. And then finally, take the square root. It will be same. You understand? Let's try. In the example, we had a random variable is an age, 19, 20, 21, and 27 with the probability, random variable. How many 19s? 2 out of 8, which was 0.25. And how many 20s? 3 out of 8. How much was the probability for 20? 0.375. Ah, yes, 375. And 21, 2 21s, 0.25. And we had only one 27, which was 0.125 or 225. Was 125, and then now the sum will be 1. Okay, now step number 1. We got the mean expectation. It was a 20 point what? 875. Step number 1, we take the mean, same. Next, we take the difference. 19 minus 20.875. 20 minus 20.875. 21 minus 20.875. And 27 minus 20.875. Okay, let's do it. 19 minus 20.875. Oh, negative 1.875. Negative 1.875. Negative 0.875. Positive 0.125. I don't know. 27 minus 20.875. The last one will be positive 6.125. So now, step 2. We take the difference. What is the next? Step number 3. We take the square. So negative 1.875 square, negative 0.875 square, positive 0.125 square, and plus 0.125 square. So step 1, 2, 3 are same. Yeah, same as before. So 1.875 square will be 3.516. 0.875 square, it is the 0.766. 0.125 square, it will be 0.016. And 2.125 square, it will be 37.516. I'm taking many roundings here, there, right? Yeah. So when you are doing the homeworks, yeah, please using more decimals. Yeah, it's 4, 5 decimals will be enough, safe, right? Yeah. So far, same. Step number 1, take the mean. Step number 2, distance, difference. Step number 3, square. Make them all positive. Now what? The new one. Step 4, it is a new one. Times the probabilities. 3.516 times 0.25. 0.766 times 0.375. 0.016 times 0.25. And the last one is a 37.516 times 0.125. So it is a new one. It's a multiply the probabilities. So 3.516 times 0.25, it will be 0.879. And 0.766 times 0.375, it will be 0.287. And 0.016 times 0.25, and 0.0039, 4. And the last one is a 37.516 times 0.125, and here is a 4.689. Step 4. It is a new one. Take the multiplication. So far so good? Now we take the sum. Now we take the sum of the multiplications. 5, take the sum. So 0.879 0.287, 0.004, 4.689. The sum will be 5.859. Finally, what? Take the square root of it. Square root of 5.859. So square root of 5.859 will be 2.42. 2.421 will be the standard deviation for the random variable. Another, almost the same, 6 steps. But we don't have to do the division by n minus 1. Instead of that, before take the sum, we take the multiplication. Can you do that? Yeah, we are going to have a quiz to get the standard deviation today, but you should understand which parts same and which parts are different. Okay. Good, right? Okay. Any question? Yeah, you can ask me later. Please look at the mean. Yeah, here was the mean, right? We take on age, each, and we multiply each probability. But, see, we had 8 ages in chapter 3. We got the average. How did you get the sample mean? Sum of divided by n. Remember that? Yeah, let's do it. Let's try. Let me take the sum. Let me take the sum. It's 19 plus 20 plus 20 plus 19, 21, 27, 20, and 21. Divided by how many? 8. Yes. Did you know multiplication is the additional summation? I mean the repeated addition? I mean the multiplication is a repeated addition. What I mean, how many 19s? 1 and 2. I can rewrite, it is the 2 times 19. What did I say? Multiplication is a repeated addition. 2 times 19. How many 20s? 1, 2, 3. So it will be 3 times 20. How many 21s? Another 2 21s. And now we have only 127. So now I can describe it as 1 time, 1 times 27. Then divided by 8. Can I do that? Can I split each term? What I mean, the first one is 2 times is 19 over 8. 3 times is 20 over 8. 2 times 21 over 8. 1 times 27 over 8. With the common denominator, can I split them? So far so good, right? It's very simple math. How about this one then? 19 times 2 over 8. 20 times 3 over 8. 21 times is 2 over 8. 27 times 1 over 8. We can switch. We can switch the multiplication. A times B will be same as the B times A. So now I can switch like that. Have you ever seen the sum? Okay, should I write one more time? 19 times 0.25. 20 times is 0.375. 21 times 0.25. 27 times is 0.125. Have you ever seen the sum? Please say yes. Up there. Before we apply the new formula in STAT25 to get the expectation, to get the sample mean. Yeah, here. We apply old one in chapter 3. Take the sum, divide by 8. But modify, rewrite. That will be same. That will be same. Okay? So simply I can say it will be same as the sum of each value divided by n. But already somebody summarized, organized the numerical variable, the discrete numerical variable with the relative frequency, with the probability. Another way, we are going to take exactly same sample. But this one, the new one, and old one, they are exactly same two equations. Okay, let's do the quiz. It is a quiz number 11. It is the random variable. It's a number of the repair codes to a store, right? The repair shop. And sometimes it's no call, sometimes 1, 2, or 3. And there is the probability. So in part A is how many expected. It's actually part A asks us what is the mean. The step number 1. What is the mean? And now part B asks us what is the standard deviation. It's the other 5 steps to get the standard deviation. So please apply the 6 steps in this quiz number 11. For the mean, we have to take the multiplication first, right? So 0 times 0.1, 1 times 0.3, 2 times 0.4, and 3 times is 0.2. They will be 0, 0.3, 0.8, 0.6. Then what? Then what? What should I do? Take them, add them up. Yes. That will be expectation. That will be the mean. And then step number 2, take the difference. 0 minus the mean, 1 minus the mean, 2 minus the mean, and 3 minus the mean. Anybody who take the mean, please, in step number 1, expectation? Anybody who got 1.7 in step number 1.7? Thank you, 1.7. So 0 minus 1.7 will be negative 1.7. 1 minus 1.7 will be negative 0.7. And 2 minus 0.7 will be positive 0.3. And 3 minus 1.7 will be positive 1.3. Next, step 3, take the square. Remember, when we take the square, always it must be positive. Positive. Then now, next, step 4 times 0.1 times 0.3 times 0.4 and times 0.2. It is a new step. Step 4. And step 5, now we can take the sum, and don't forget, take a square root. Square root of the sum to get the standard deviation. If you need help, please ask me. Already I posted the homework number 11. Yeah, take the standard deviations. Will be due Friday. Another 6 steps, but they're almost the same. We don't have to do division by n-1. The very first one is a 0.289 after you take the multiplication 0.1. I think square one must be 2.89. Am I right? And times 0.1 will be 0.289. And keep going. 3 more. And take the sum. Take the square root of the sum will be the final answer. Another 6 steps.
Yeah.
Yes. Where are we leaving?
We're Friday.
Where?
We go to Cameron and YouTube Tyler. Yeah.
Please.
Yeah. We're gone until Saturday night. Yeah, that's a lot.
Uh-oh.
Yeah.
You're right. Please take us some of it. Don't go home. Sit at the kitchen. This is one. The third one. Oops. And multiply each probability. 2.8, the green one times red one, 21. Yeah, it's one more step. You missed the one more step. A little bit. It's a 147. Yeah. The second one is 147. last one is wrong. This is wrong. Try again 1.3 squared. Try again 1.3 squared. Yep, you're right. Oh, I think this is wrong. This is the 0.4 and 0.2. Oh my god, where did you get that? Good. Yes, 0.338. Good, thank you. You're good. Good one. Absolutely. It is it must be 0.338. 1.693. 0.2.
Wait, is that wrong? The wrong, is that one?
It is this one, don't worry. It's a 36. And the next one is this. And the sum will be another one. Yes. Perfect.
Is this right?
Yes.
What's the second step?
Yeah, good.
That's good.
Good. Yeah.
There's only 6.
Only 6 steps, yes. Another 6 steps.
Okay.
How much did you get? 80. Yes, looks good. Looks good. Thank you. And then
You should.